Good morning everyone. So for today class chemistry, we're gonna enter a new chapter. Okay, chapter 20, the atmosphere and environment. Okay, so the first slide shows that Joseph Priestley, this is the scientist, a young and very intelligent scientist. He is the first who conducted experiments and observation of different kinds of air. He is also the one who studied or determined the oxygen gas. And he also made the history, who invented the first carbonated soft drink. If you want to learn about more detail about Joseph Priestley, you can look in the internet, right? So what does air consist of? So normally we take air for granted most of the time. We breathe in air and cannot live without it. So basically what is air? So this is the definition of air. So air is a mixture of gases largely consisting of nitrogen, and oxygen gas. Other gases present in small but nonetheless significant amounts, which are carbon dioxide, water vapor, H2O, and noble gases which include the argon, neon, and helium. So you have the tables here. Shows that the composition of clean, dry air, water vapor is not present. If you look on the one, nitrogen is the highest, 78%, followed by oxygen, 21, and then the last one will be the noble gases, which is mainly argon, and CO2 combined it will become 1%. All you can do in pie chart, the blue color here, the biggest one will be known as a nitrogen, followed by the second largest, you have the oxygen, and then the second smallest will be the noble gases, which is mainly argon. The last smallest one will be the carbon dioxide, 0.03%. So as air is a mixture, so its composition varies from time to time. From time to time, which means that let's say daytime, in the morning, and nighttime. Let's say if you compare the carbon dioxide, and then we compare with in the city, let's say in the night, at the night and at the morning. At the morning, of course, the concentration, or the amount of CO2 will be much higher compared during at the night time. This is because in the morning, normally the industrial, will start to operate, and also there is a lot of vehicles on the road. So normally carbon dioxide is coming from the release from the industrial, and also the vehicles. Compared to night time where there is no people walking, normally there is no people walking. So the industrial during that time will be closed and less vehicle will be on the road. So which means that night time the concentration or the amount of CO2 will be less. So that's why the composition of the air is always varies. From place to place, of course, if you compare with city and urban areas, in the city, of course, the concentration of carbon dioxide is much higher compared to in urban areas. So separation of air into its components. So let's say you get the first one, air. So the air will be undergoes the stage 1. The process is cooling and compress. Compression. So after that it will become liquid air. So liquid air, which is after that we undergo the stage 2. The process is known as fractional distillation. Liquid air is then separated into its constituent or fractions by the process known as fractional distillation. At the top here and the bottom here. At the top here will be the small, let's say the smallest boiling point. Compared to the bottom one here will be the high boiling point. So at the top here will be released first. So that's why here is stated distill above first. So nitrogen will be released first, because it has the contain the least or smallest number of boiling point. Followed by argon, then followed by oxygen at the bottom one. At the top release over first. So this is the explanation about the fractional distillation of air. So the air is first filtered to remove dust and then cool in stages until it reaches negative 200 degrees Celsius. So at this temperature, the air is in the liquid state. Okay, for example, like this, now is liquid air. So water vapor and carbon dioxide freeze at higher temperature, okay, and are removed using absorbent filters. So the normal gases are still in the gaseous state, okay, which means negative 200, leaving a mixture of liquid nitrogen and oxygen. So that's what you have here, okay. So you have the nitrogen, okay, normal gases and oxygen. So the liquefied mixture is passed into a bottom of a fractionating column. Note that the column is warmer at the bottom. Okay, the soda it has a higher boiling point. Okay, than it is at the top. Oxygen liquefy at negative 183 degrees Celsius and nitrogen liquefy at negative 196 degrees Celsius. Okay, so nitrogen has a lower boiling point than oxygen, so it vaporizes first, okay, distilled first, and is collected as it rises in the gaseous state to the top of the column. Okay, the liquid oxygen is then removed from the bottom of the column. This one here. Nitrogen will be released first, okay, vaporized first. So this the diagram shows the fractional distillation of air. Okay, colder at the top, warmer at the bottom. Okay, so that's why here the temperature here is smaller, okay, compared to this one, okay, higher. Okay, so this the basically is the step. Okay, so let's see the number one here. Air has to be condensed into a liquid. Okay, this happen at negative 200. Okay, remember that this one. Okay, you get the air, then it must be cooling and compression. Okay, undergo this to become liquid air at what temperature? This one. Okay, negative 200. Okay, then go to the next stage. Okay, this is done by compressing or squashing the air and the use of cold water. Okay, this is the explanation for number one. So at negative 200 degrees Celsius, okay, carbon dioxide and water are solids, so can be easily taken out. Okay, so number four here, nitrogen boils at negative 96 degrees Celsius, so it can be removed from the top of the column as a gas. Okay, nitrogen go here first. So at negative 185 degrees Celsius, oxygen is still a liquid, so can be taken out the bottom of the column. So it coming out here is the oxygen, here is the nitrogen. Okay, so this is a new one, a new thing. So finding the percentage of oxygen in air, here you can conduct this experiment here. How can you find the percentage of oxygen in air? So let's say here a known volume of air it passed through a tube with burning copper powder, this one, copper powder, the brown color here. Okay, and oxygen in air. Inside here you will find air. Okay, so we react with hot copper powder. This oxygen will react with the hot copper powder because you heat it. Okay, you heat this copper powder and then you produce a copper oxide. So this is the reaction, the equation. Copper burn, okay, burn with oxygen, so you form copper oxide, black, okay, color. So if oxygen is depleted, okay, so the readings on both strings, this is the strings, okay, 1 and 2, okay, will be steady and the reaction has completed. Okay, that is the case for if the oxygen is depleted. Okay, so therefore, to find the volume of oxygen in air collected in the syringe, so you have this formula. Okay, volume of oxygen that you want equal to initial volume of air minus final volume of air, so you will get the volume of oxygen. Okay, so for example, like the initial volume of air in one syringe is 80 cm cube, okay, and the final volume is 64. So you just take this one and this one, okay, minus, you will get this one, okay, 16, okay, because you want to find the volume of oxygen in one syringe. Okay, divide by initial volume of gas in one syringe, so just take initial volume, so this one, so it is so here is initial volume is 80, so 80, so you times 100 percentage, you will get 20 percentage of, okay, volume of oxygen. Okay, that is how we can find the percentage of oxygen in air. Okay, remember this formula and also this formula, right? Okay, so in combustion, okay, combustion substance react with oxygen producing heat. Okay, the product of combustions are oxide. Okay, see the following table. So this is the let's say the reaction. Okay, let's say the substance burn. The substance we have hydrogen, carbon, magnesium. Okay, compound here. Then you have the names and the formula of the product. Okay, appearance. Okay, and then the equation for combustion. Okay, let's see one by one here. Let's say hydrogen. Okay, if you burn this one, okay, this one, hydrogen gas burn, okay, or undergo combustion. Okay, undergo combustion means you have to plus with oxygen. Okay, so you form into the product will be known as water. Appearance of the oxide is liquid. Okay, let's see carbon here. Carbon heat with the oxygen because this carbon undergo combustion, right? So if I say combustion, which means you have to plus with oxygen. Okay, oxygen gas. So C plus O2 will give you carbon dioxide. Okay, appearance will be gas. Okay, magnesium burn with oxygen, it will give you magnesium oxide, solid. Okay, sulfur, it will give you sulfur dioxide, gas. Okay. How about compounds? Let's say methane. Methane is CH4. Okay, the chemical symbol. So if you burn the methane, CH4 plus with O2, it will give you carbon dioxide and water. Okay, appearance of oxide, it will give you gas and water, liquid. Okay. So for ethanol, if you burn ethanol with the oxygen here, okay, this is the chemical formula for ethanol, the alcohol. So it will give you, same goes to previous one. It will give you carbon dioxide, CO2 and water. Okay, in appearance will be in liquid. Okay, so this is the combustion. Okay, for this one is a complete combustion. Okay, complete combustion. The next slide show you the incomplete combustion. Incomplete, which means the amount of oxygen is not enough. Okay, as I say, combustion, you need oxygen, okay, in order to happen. So let's say the A, okay, first point here, when substance containing carbon are burned, okay, the carbon becomes carbon dioxide. Okay, if plenty of oxygen is available, okay, we call that as a complete combustion. But let's say if there is insufficient, not enough oxygen for complete combustion, okay, so the carbon becomes carbon monoxide, not become carbon dioxide, okay, it become carbon monoxide. So this is a we not call as a incomplete combustion. So carbon monoxide is a very poisonous gas, so it is dangerous because it has no color or smell, and so it is not easily detected. Okay, besides carbon monoxide, gas soot, okay, which is carbon, can also be produced during incomplete combustion. Okay, remember the product, okay, when you have an incomplete combustion, which means the amount of oxygen is not enough, you have the product is carbon monoxide, okay, and soot. Okay, incomplete combustion take place, okay, in car engines when petrol or diesel fuel is burned, example here, or in cooking fires in tanks, okay, if there is inadequate ventilation. Okay, so this diagram shows the complete combustion and incomplete combustion. Okay, complete, which means the amount of oxygen is enough. Incomplete, which means the amount of oxygen is not enough. Okay, sufficient and insufficient. Rusting. So what I mean by rusting? So rust is a brown solid. Okay, it is mainly iron oxide produced by a reaction of iron or steel with oxygen in air. Okay, so condition needed for iron to rust. Okay, it needs oxygen and water to happen. Okay, must be present. So how rusting is prevented? Okay, by coating the iron or steel with a layer of substance that stops water and air from reaching the metal. For example, like cover with oil or grease. Okay, normally it is used in machines such as engine and bicycle chains. Okay, for painting. Okay, used for car, iron railings, ships and bridge. Okay, coating with another metal. Okay, this is known as cans of food coated with tin chromium plating. Okay, so B here, by coating the iron or steel with a more reactive metal that corrodes instead of the iron, for example, like coating with zinc in galvanized iron. Okay, so this is how you can, A and B show you the how rusting can be prevented. Okay, so this diagram shows, okay, how the rusting happen. So in order rusting happen, you need oxygen and water. Okay, this is the iron, so it become like this. Okay, in real life, okay, it is called the rusting. You can see the brown color here. Okay, this is called rusting. Okay, so in this diagram, it will show you this is the water. Okay, you have the air. Okay, you have the rust deposit. Okay, which is formed. Okay, it's already formed here. Okay, so uses of oxygen here. Okay, the number one here, making steel. Okay, reason for use, oxygen used to burn off the impurities in the iron. Okay, second one, oxygen tanks in hospital. Oxygen is used, okay, to help people to live. Okay, welding. Okay, oxygen is used to burn. Okay, acetylene, okay, gas. Okay, the high temperature of the reaction melts the steel. Right? Okay, now we go to the second subtopic. Okay, air pollution. Okay, common air pollutants and its effect. Okay, so what is air pollution? So as you can see, so we can see this is the industry. Okay, the livestock area. Okay, where you have the farmer or the animals. Okay, fertilizer, oil and gas. Okay, this is the forest. Okay, wildfires. This is the cities. Okay, you have the vehicle here, different kind of vehicles, and also the mobile vehicle. Okay, mobile, which means you can moving vehicles. Okay, moving vehicles. So what is air pollution? Okay, so this is the definition for air pollution. So air pollution is the condition in which air contains a high concentration of certain chemicals that may harm living things or damage non-living things. Okay, so air pollution is caused by solid particles and poisonous gas in the air. Okay, these air pollutants include carbon monoxide, okay, oxides of nitrogen, and sulfur dioxide. Okay, okay, so let's study each of the pollutants. Okay, carbon monoxide, so major sources. So incomplete combustion, previously I already mentioned. Okay, where you have the incomplete combustion, you will release carbon monoxide. Okay, so incomplete combustion is a major sources of for the carbon monoxide. Okay, of carbon containing substances, for example like charcoal, wood, petrol, and etc. and so on. Okay. So harmful effects from the carbon monoxide. So react with hemoglobin in the blood to form carboxyhemoglobin. So the hemoglobin cannot transport the blood to the rest of the body. Okay, if your body get lack of the oxygen, so you will get, okay, your body cannot undergo some of the chemical process. Okay, eventually you will die. Okay, so causes headache, okay, fatigue, okay, tired, okay, breathing difficulties, or even death. Okay, the second one will be the oxides of nitrogen, nitrogen monoxide, KNO, this is the chemical symbol, and nitrogen dioxide, KNO2. Okay, major sources, reactions that occur in car engines, okay, internal combustion engines, okay, or from the lightning, okay, the natural phenomena, lightning. So this process takes place. So nitrogen react with oxygen, okay, N2 plus with O2 to form nitrogen monoxide, KNO, gas, okay. So and then again, nitrogen monoxide will react with oxygen to form nitrogen dioxide. Okay, NO plus with O2 again, it will give you nitrogen dioxide. Okay, so the harmful effect will give you, okay, eye irritation, okay, breathing difficulties, okay, lung inflammation, which is known as a bronchitis. Okay, also we will, okay, uh, cause acid rain to happen. Okay, the third one will be the sulfur dioxide, SO2. Okay, major sources will be coming from the combustion of sulfur, which containing fossil fuels. Okay, especially the coal. This is the one, the coal, the color. Okay, all the volcano eruptions, for example like this one, the explosion of the volcano. So the sulfur react with oxygen in the air to form sulfur dioxide. Okay, when the volcano is explode, okay, it will release the sulfur. So the sulfur will react with the oxygen surrounding here. It will form sulfur dioxide. Okay, the harmful effect will be eye irritation, okay, breathing difficulties, lung inflammation, bronchitis again, and acid rain. Okay, so other pollutants will be include unburned hydrocarbons, methane, and also ozone. Okay, so unburned hydrocarbons are released in the car exhaust. This one, unburned hydrocarbon. Okay, this is a vehicle, so it will release normally is carbon monoxide, nitrogen oxides, hydrocarbons, particulate matter, and sulfur dioxide. Okay, as you can see. Okay, so the difference here between here is, okay, blue one is all cars. Okay, only diesel car is for the red one here. Okay, so there is the from vehicles. Okay, what type of gas release? So methane is a colorless and odorless gas produced when plant and animal matter decay. Okay, decompose. Okay, same meaning as decompose. Okay, it is also produced from the decay of rubbish in landfills. Okay, as you can see, okay, this the diagram shows the cow. Okay, when the cows, okay, let's say the stomach, okay, release the air from the outside. Okay, there's a simple facts about the when it release air into outside from the cow's body, it will release methane gas. Okay, you can try to look in the from the internet. Okay, actually when the let's say the cow is okay releasing air, okay, it will actually release some small proportion of methane, okay, coming from the cow. Okay, methane is a greenhouse gas. Okay, so effects of acid rain. Okay, this one. Effect of air pollution. Okay, the acid rain. So rain usually has a pH that is slightly below 7. Okay, why? Because carbon dioxide in the air dissolve in the rain water. Okay, carbon dioxide is acidic. Okay, so it become carbonic acid. Okay, carbonic acid is a very weak acid. So however, acid rain has a pH value of 4 or less. Okay, so this shows you how the acid rain happen. Okay, you have the acid rain. So actually starting from here, coming from the industry area and the let's say this is the vehicle. Okay, so it will react with the oxygen here. Okay, and then it will form into acid, sulfuric acid and nitric acid. Okay, when there is an acid rain, okay, a lot of damage can be done. Okay, for example, like acid corrodes, okay, damage the buildings and metal structure. Okay, it will also kills the fish here. Okay, aquatic animals. Okay, also will destroy the tree, damage the green leaves. Okay, also destroy the soil. Okay, pH value of the soil. Okay, so this is the explanation of how the acid rain is formed. The acid rain is formed when acidic air pollutants such as sulfur dioxide (SO2) and nitrogen dioxide. Okay, remember this one. Okay, NO2 and SO2 dissolve in rainwater. Okay, firstly, sulfur dioxide dissolve in water to form sulfurous acid. Okay, H2SO3. So this is a chemical reaction. SO2, sulfur dioxide react with water. When water, H2O, it will give you sulfurous acid. So in the presence of oxygen in the air, acid is slowly oxidized to sulfuric acid. Okay, as you know, sulfuric acid is a very strong acid. Okay, so in the presence of oxygen and water, nitrogen dioxide is converted to nitric acid. So this is the nitrogen dioxide react with water. When water and oxygen, it will give you nitric acid. Nitric acid also known as a strong acid. Okay, so all rain is acidic with or without air pollution. That is due to the natural presence of carbon dioxide in the atmosphere, which dissolves in raindrops of rainwater. Even moisture present in the atmosphere does the same function, okay, to form carbonic acid. Okay, so this one is a carbonic acid. Okay, it's a very very weak acid. So CO2 plus with H2O, you will give you carbonic acid. Okay. So due to the above reactions, carbon dioxide can dissolve in water until solution becomes saturated. So the result in the rainwater attaining an acidic pH of 5.6. Okay, due to this, the purest form of rain reach the earth as an acidic solution of pH 5.6. Right? So effect of acid rain. Okay, the effect. So as I said, it will corrode or damage the building, just such as the fences and bridge. Okay, and they react with carbonate in the marble, okay, the building structure and limestone. When this happens, it will damage the building. Okay, reduce the pH value of natural water bodies to below 4. Okay, too acidic, it will kill the fish and other aquatic life. Okay, so leaches important nutrients. Okay, wash away all the important nutrients from the soil. Okay, this will eventually kill the plants. Okay, wash away. Okay, leaches. Okay, alright, so that's all for today's class for chemistry. Okay, thank you for watching and listening this video.